Hi, this is Mr. Manley, and this is a lesson on graphing, something that you've been doing for quite a while. And what I want to put the focus on here is the idea that you can graph really any equation, even if it's unfamiliar to you. The place that we would begin is by finding the X-Y intercepts, understanding that really what we're going for is just to find enough points in a table of values so that we can graph any equation. And the first 2 points that we're going to find are the x-intercepts, or the X and Y intercepts. When x is 0, think about that. What are we finding? If we let x be 0 in an equation and we find y, we are finding the Y-intercept. And if y is 0, of course, we're finding the X-intercept, and it could be intercepts. Typically, there's only one Y-intercept. Certainly, if we're talking about a function, there's only one Y-intercept. And for the X-intercept, there could be more than one. So this is the first thing to think about as far as graphing. So let's take a look at a few functions, a few equations. Maybe you see this and maybe you have an idea of what it looks like. Maybe not. Here's another one. I'm trying to look at a absolute value function here. And here's another one, just a parabola, right? So if we go back here, whether or not we know anything about the function, what I'm saying is that we can always begin with 2 points, the X and Y intercept. So I let X equals 0. So up here in this equation, I'm going to let X equal 0, and I get Y is equal to -1 when I let X equal 0. And I've got the Y-intercept, and then I let Y equal 0. And when I let Y equal 0, I have X cubed minus 1 is equal to 0. X cubed is equal to 1, and X is equal to 1. So I've got the X-intercept. And that could get us started on the graph of this function. Now, it may be that we might remember now what this graph looks like, or it may be that we need to find some additional points in order to get a clear enough picture of what the graph looks like. All I really want to talk about here is just finding the X and Y intercept. So let's look at that for this one. Think about the X and Y intercept for this. And we're going to let X be 0. And when X is 0, Y is 1. And then we're going to let Y be 0. Usually, I don't have to write anything down for X is 0. It's just I let X is 0, and then I go, okay, well, if that's not there, what's left? And then that's the Y-intercept. With Y equals 0, though, oftentimes I want to go ahead and write that out and then solve for X. So let's see what I've got here. I've got the absolute value of X is equal to, looks like 1, right? Because I'm going to go subtract 1 there, and then I'm going to divide that by -1. So it's going to be a -1 over a -1 is 1. So I got absolute value of X is equal to 1, and that's going to be X is equal to plus or minus 1. Hopefully you remember what to do with your absolute value in this case. So you see here we have 2 X-intercepts, plus and minus 1. And then looking at this last one, simple enough. This, I thought it is a parabola, but it's not the parabola that I was thinking. This is a sideways parabola, right? So it's actually not a function, if you know about that sort of thing, but it is an equation that we can graph nonetheless. So let's take a look here. When X is 0, okay, now in this case, I can't just go here and cross out the X and go what do I have for y? I have to do a little bit of solving. So let's go x is equal to 0. So I've got y squared minus 5 is equal to 0. Y squared is equal to 5. Y is equal to plus or minus the square root of 5. So do you remember how to get from this to this? Go ahead and take a look at that. Y squared equals 5, and that brings us to y equals plus or minus the square root of 5. And those are the y-intercepts. So at the beginning I said that we only have, if you recall on the first page here, I was saying we only have one y-intercept, and you might have caught me, I might have said something about it being a function. So if it's a function, there's only one y-intercept. This is not a function, and there's a kind of nuance in the definition of the equation and why this is not a function and what that means. But anyway, that's the reason there's more than one y-intercept, or that there can be more than one y-intercept here. Okay, now I'm going to let y equal 0 to find the x-intercept. And actually for that I can do what I was doing for the other one. So I can just go, oh, there's y is 0, and that leaves me with x is equal to negative 5, right? So let's go y is 0, and then x is equal to negative 5. And then for all of these, like just to take this one for instance, so what I would do is I could go ahead and get started on graphing it. So I've got these points and I've got the graph here. And so if I go 0, positive rad 5, but what's positive rad 5? That's going to be something between 2 and 3, right? So it's going to be in here somewhere. And then I would have a negative rad 5 in here somewhere. And then I'd have negative 5, 0. So I'm going to graph this point, negative 5, 0. And I've got a point, a point, a point. And if I know enough about shapes and I know enough about expressions, I really have enough information here, right? I can go and finish this graph without any additional points. So we may or may not be able to do that with any function, with any equation. This other one back here, and we take and put those points on a graph, and I got 0, 1. So if I take that one, x is 0, y is 1. And I take these here, x is 1 and negative 1. That's here and here. And again, I know what an absolute value function looks like. Maybe you do too. And we know that that is going to look like this. Okay? All right, now for each of these, we're also going to look at, you might have seen on the first page here, we're also going to look at symmetry. So back here, remember that there's that word symmetry. And here's the way that's working. I'm not going to do it for all of them. I'm just going to do it for one of them. So I'm just going to look here and say, what is the symmetry? What kind of symmetry does this have? So here's how that works. For symmetry, and for x-axis symmetry, I plug in negative y, and then I simplify the equation and see if it's the same as it originally was. And if it is, then it has x-axis symmetry. For the y-axis symmetry, I plug in a negative x into the equation, and then I simplify it and see if it's the same or not. And then for origin symmetry, I plug in negative x and negative y. So let's go here. For x-axis symmetry, I have x equal to negative y squared minus 5. And then when I simplify that, I get the same equation I started with. So this equation does have x-axis symmetry, which we can see here, right? This is symmetric across the x-axis. And then for the y-axis symmetry, I plug in a negative x, So that's negative x equal to y squared minus 5. There's nothing I can do as far as simplifying it. So that does not have y-axis symmetry. And then for the origin, let me go to a different page here. So here I went ahead and plugged in negative y and negative x into the given equation, right? And then, so I've got that here, and I want to simplify it. So what do I have? I have negative x equals y squared minus 5, and no, see, this does not match this, so it doesn't have origin symmetry. And just for your information, an equation that does have origin symmetry, I'll show you what that looks like. This is the graph of an equation, this graph here that has origin symmetry. And the idea is if I took any point on it, and then I went to the origin, and then I went the same on the other side, I would have another point on the graph of the equation. Okay? So, as always, if you have any questions, bring them to class or tutoring.